So
Oh.
today's presentation is going to be on Lochinvar Smart Control. And really, before I start into the PowerPoint presentation, one of the things that I thought of talking about is what consists of the smart control itself. I mean, behind the scenes, it's software, but what are the components and what are the pieces? So basically, on each one of your products, you're going to have some sort of display screen or bezel that holds that display screen. Okay. Now, behind the bezel is just the display portion of the smart control itself. It's real important to understand this is not the control. This is merely so you could see what's going on and that you can program it. That is all that this interface is going to do. Nothing more than that. The control itself resides on board the main control board. The main control board connects to the display interface. And then basically from here, everything goes out to the boiler. We connect to all the sensors, we connect to the fan, we connect to the gas valve, we get to 24 volts, we do everything like that. So that's really, this is where everything resides on board here. Now, a little over a year or so ago, Lochinvar did make a change in the whole process. And if you have a B model that's referred to as a KHB or a WHB, what you will find is that you have the advantage of your programming can also reside on the display. So if you change a board, you can actually download all the programming right back into the new board using display. That's specific to the B model only. So that's kind of an overview of what actually is the smart control. Well, it's basically somewhere on board this guy right here is where it is. If you were to add connexus to your boiler, and that's the simple process of you insert a card in between these two boards right here. And that's really all that you do. And what that does is it emulates this up onto the internet. So that's how connexus works. All right, so let's go ahead and get started and jump into the smart control itself. All right, so Lochinvar introduced the latest generation of smart control back in 2010 is when they did that. And what they did is there was a little transition between the green screen control, it's a two-line green screen, and the blue screen, which is now really developed into a little more robust kind of a gray screen. And then the newest, latest, and greatest we see in our Crest product, which is the big display screen. But that's what we're looking at, and that's what we're going to talk about today, are mainly these products you see right here on your screen. So a couple of different colors that go on within the screen as to what we're looking at and what we see. And in that, when we look at that screen, there's three colors to the screen now. There's the blue screen, that's normal operation. Now that blue backlighting generally only stay lit for 2 to 3 minutes. That is adjustable in the control parameters if you want to make it longer. But when you touch it, the backlighting is going to come on. It's that blue backlighting. Now, the yellow screen, that's maintenance required. That's like a change of oil light coming on in your car. That's really all that is, really nothing more than that. If you do program your company's name and phone number or your name and phone number on screen, when it's time for a service, that's going to come up and give it name and phone number. And you program how often you want that to happen. Now that could be by months, that could be by hours of operation, and that could be numbers of ignition cycles. Generally, I'd recommend using months, okay? Anywhere from probably 12 to 18. I wouldn't stretch out much more than about 24 months, put that in there. And then the red lockout screen. Red lockout screen, something requires immediate attention. The boiler is in alarm and it is not firing. And it will alternate between what the lockout is and your company's name and phone number right down here at the bottom. Real important, we get a substantial amount of calls from people. My boiler's locked out, I've got no heat. Hey, what are you locked out on? Well, I'm locked out on lockout. And that is the way the screen's going to read at the top, but go right down here, and that's going to tell you what the lockout itself is, okay? My clicker button working here. There we go. Now there's the low voltage connection board. That's the other part of the smart control that I didn't show to you guys on here. As far as the piece that I had here, So now this is where your wiring is going to interface into the smart control itself. Just a couple of things to note on there. There are 3 heat demands. The boiler does take 3 separate temperature demands. Um, why would I use that? Maybe I've got radiant, maybe I've got hydro air, and I've got some baseboard together in that. And I might do that and set that up that direction. Other thing to notice, we could take a tank sensor and we could take a tank thermostat call. They are different. So if I'm using like a Honeywell 4080B Aquastat, I land on tank thermostat. If I'm using a tank sensor, you know, 10K sensor that goes in the well of the tank, I'm going to connect that to the tank sensor terminal. So it's just important to note which way you're doing. One spot where people do get a little confused is the older style Weil McLean and the Stadler tanks that have that built-in dial on the top and have wires coming out of it. Those will land on tank thermostat because that's a tank thermostat. It's not actually a tank sensor. So just make sure you use those correctly. And if you do look at it, the board itself, just from a troubleshooting perspective, the right-hand side of the board, that's all 24-volt terminals. The left-hand side of the board, we're getting into DC terminals and resistance terminals. Our sensors are based on resistance. We do have some DC input and output terminals on that other side as well. So just know which side of the board that you're on. If you're not certain, the 24-volt side actually does have 2 items on there that are labeled 24-volt, and that'll give you the clue as to what side of the board you're on. Lock and Link, it's a feature that came out with the latest generation of the smart control, 2014-ish. That gave us the ability to plug a USB thumb drive into it. So you can have programming pre-programmed on a thumb drive. We make available from us thumb drives that have some generic, if you will, programming. You'll put it in and you'll say, hey, I got baseboard, I got hydro air, I've got radiant. It's going to give you some very general conservative settings. Just a good thing to, hey, you don't want to struggle setting up the control. You don't want to go through all that. Boom, I'll just put that in there and it'll be done. Take you about 30 seconds. The other side is, if you run a plumbing heating company or an HVAC company and you're sending your guys out in the field and you have certain things you like to program, you can go right ahead and pre-program those thumb drives and send them out with your guys, and they can go ahead and just upload that. If you need a pre-programmed thumb drive, you get that through your Lochinvar distributor, or reach out to one of the FIA sales team and they'll get them for you. If you want to set up your own thumb drive, you just need a regular USB thumb drive to go right ahead and do that. Okay, it plugs right in there. And here's the gratuitous animation slide that we have as to how it plugs in. It's a terrible job at docking right there. All right. I'm going to shift back right here just mainly because this whole presentation is built around the 2nd generation, but everything's going to program the same and do the same. And this one actually displays just a little better as we walk through the interaction and the navigation of it. Okay. So first off, that's where we're seeing everything that goes on. That's that small board that I held up for you before. That's it right there. What it's doing, that's going to be the top. Standby, start, ignition. It will show the boiler actually firing, shows a little flame, and what our firing rate is. That's all going to display across the top. To the right-hand side of it, when it's in operation, it'll let you know, do I have a heat demand or do I have a domestic hot water demand? That's going to show up right there. Step down, these are our temperatures. Now, 2 of those are actually external sensors, the system sensor and the outdoor sensor. When you attach those sensors, they automatically display. You don't have to program it. They're just going to be right there showing you that they're actually there and going. The scroll knob, that kind of moves us through everything. We use it for a couple things. Maneuver through screens, changing the decimal places when we're programming. So that's what that does. We also use it as kind of an enter button, if you will. When you press on it, it's going to work. In this case, it's actually showing you on the screen that down arrow. That's indicating you push the button, the scroll button in to activate that feature there. The select buttons, now they're marked select because they change from time to time. What you'll see on here is the menu and shutdown directly above it. That's telling you what those select buttons are right now. From time to time, you might see them say save, exit, home. They're changing their function, but it's still lining up with that select key. That's what those indicate for you there. Reset, reset the boiler out of a lockout. It's the only thing that that does right there. Doesn't reset a parameter that you programmed or anything like that. It just resets a manual reset. And the service button. So the service button right there, underneath that is going to give you so that service button there is going to be able to set the boiler into the service mode of firing. Okay. Now, underneath that is a just a little, I don't even know how to describe it. It's just a little button. Use a paper clip, put your paper clip in, and now they tell you hold it for 5 seconds. These are Southern boilers. 5 seconds is longer in the South, and I think it depends on what month of the year it is as to how long that takes. So what you want to do is you want to hold that in there, watch your display screen. It'll come up and say service. So once that happens, then you can release the button. Now, when you do that, the boiler is going to fire to 100%. Tap it again, your boiler will drop to its minimum firing rate. If I have this blue screen right here, this one with the gray bezel, that's 20%. That's its minimum firing rate. If I have the red bezel, like I showed you earlier, that's 10%. That's its minimum firing rate. Now, once the boiler is in that service mode, we go back to that knob and we could actually adjust the firing rate with the knob. Where does that come in handy? Well, let's say that Tommy calls me up and says, hey, my boiler makes noise at 37%. When I go out there and I want to see what he's doing, I could put it in service mode and I could dial that knob to 37%, and we could go and look. We could take combustion at 37%. We could hear what it's doing. There's a lot of things that we could do by adjusting it. Another spot that I've used that is sometimes on a new installation, they've got an undersized gas line or an undersized gas meter, and we use that to figure out where are we running out of gas. And then when we get to ramp delay later in this presentation, we'll show you how to cap the boiler so that it doesn't go over that firing rate. So an example being, you put a boiler in, you put a 285,000 BTU boiler, it's not running when you get up there, you find your gas dropping off, you use that to find out, hey, where do I run out of gas? Let me hold my boiler until I can get the gas company there, take care of the problem, get my customer through. So it's certainly a neat little feature you can do a whole lot of stuff with. This is it's a connection port for us to connect a laptop to the boiler and use our smart system software, the smart PC software. Not a whole heck of a lot that's available for you guys to do. For us on the service side, there is some stuff that we can do as far as trending boilers and looking at that. So we'll use it for that. If you're really bound and determined to use it, go right ahead. Sometimes it's kind of cool to watch that screen, because on that screen, when you connect your laptop to it, and you download the software from our Lochinvar U website, what you can see is everything. Every sensor, everything it's doing, what's the fan doing, the fan feedback. So if you're a real boiler nerd, that's kind of cool. And also if you want to program everything at once, that's a great way to do it and see all the different parameters. So that's what we use that port for. All right, just real quick, I'm going to walk us through the newest display, and what you'll see is basically behind the screens everything's the same. But this is our red screen. One thing Lochinvar did to kind of mess with everybody just a little bit, the second generation, that little service pinhole was over here, and just because, decided to move it over here. So it's over there now. So when you're in that dark basement, you're looking for it here, you're gonna have to look to the other side. It's right in the middle of the K. Just walking through the screens. We put more information on the screen. As you got here, we got a little different style of screen, but again, all the same features. I've got that USB memory stick now. I've got my PC connection port, my reset buttons, my select, and my scroll knob are all going to operate the same. Just rolling you through some of the different displays that you'll see. I'm going to stop here for a second. I want to talk about cycling of the boiler. We do talk about this in the service class, but this is where you find it, okay? We're looking at runtime and cycles right here. So if you do the math right here, I've got 100 cycles for 200 hours of runtime. That means that boiler was running 2 hours every time it lit. That's outstanding. In our fire tube boilers, we really want to see no more than 6 cycles an hour. Like to get it down as low as possible. And in our water tube boilers, we want to see those no more than 10 cycles an hour. Okay. And that really just gets into the longevity of the product plus the efficiency. All right. So I'm looking at, I want to look at the last 10 faults. It's going to take me right here. Okay. Then I'll actually use the button to move in between. I'll press that scroll knob in, and that'll cycle me through when the faults were. And this screen right here, this is probably my favorite addition to the 3rd generation of the control, is this display here. I see every sensor and every temperature. And if the boiler were actually firing in this picture, it would show you the firing rate. This is a great way to kind of take a look and say, hey, what's going on at this moment in time in the boiler? What's my system temperature? What's my outdoor temperature? You get to see everything all at once. It's just definitely a good troubleshooting screen sometimes. Somebody says, hey, it's just not warm enough. I don't think I have heat. And you come down here and you say, geez, I got water coming out of the boiler at 180 degrees, and I got a system sensor that says it's 70 degrees. Could be a problem right there. You know, we could have a distribution problem. So definitely some good stuff to look at on that screen right there. All right. What happens when I get a call for heat? This is what we're going to look at here. What does this display tell us as we look at it? Left-hand side, I'm showing a system heat call. Right-hand side, a domestic hot water call. How can you tell the difference? Well, the 2 is lit up with the house on it. What does the house mean? Well, we had 3 different temperature demands. So right now it's showing you that all 3 temperature demands are calling, 1, 2, and 3. It's telling you by putting that house over number 2, that number 2 is calling for the warmest water right now. So it has basically priority. Priority is not a great term, but it is a temperature priority, okay? Because the boiler's not controlling pumps other than a system pump and a domestic hot water pump. But the highest water temperature will always get priority. So keep in mind, if you say, hey, I'm going to put my radiant on here and I'm going to put my hydro air on here, your radiant will still need some sort of thermostatic mixing valve to protect it in the event of a higher temperature demand. So just keep that in mind. Now down below there where I've highlighted with the red box, then any number that's in parentheses is a target temperature. So right now in this case, the system is at 76 degrees. The boiler is targeting 140 degrees. We have 81 degrees coming out of the boiler, okay? If we jump over here to domestic hot water call, 2 things have happened. 1, I now have the hot water spigot, clue for I've got a domestic hot water call. And then the other thing that I have here is that 180, the outlet temperature, is now in parentheses. So in this scenario, that domestic hot water is piped directly to the boiler. So the boiler has turned off the system, the boiler pump. So it's no longer injecting to the system loop, and it's headed right out to your domestic hot water tank. Because it's doing that, it's no longer targeting the water up on the system. It's targeting it coming right out of the boiler, because that's the only spot it's going. And that's why that change is there. So the boiler knows. If it were trying to target it on the system, the boiler would overdrive itself. That's why we moved to that different spot of sensing and targeting. All right, let's talk a little bit about auto and manual reset high limits. My recommendation is leave them alone. Every once in a while, people change them. You really don't need to. Remember, you have a low mass boiler. So there will be drifting temperatures. You could get some extra energy sometimes dumped into the tank temperature within the heat exchanger. So if I said, boy, I 210 makes me nervous, 200 makes me nervous, I'm going to set it to 190, and you're running your boiler at 180, which will let it go to 185. If it shuts off at that temperature, you could see a little bit of stack from that 185 to maybe 190 and trigger a high limit reset. So keep those up and out of the way. Whenever you're done doing any of your programmer settings, you hit that exit button and it'll take you back. Home takes you to the home screen. And when you do that, you will see a message that says parameters uploading. That lets you know that you've done it correctly. So after you've made all your changes, you hit that, you get parameters uploading, you know that you're putting all of your stuff up on the on the board, moving it to the main board, if you will, from your display. Because as we program all our stuff, we hold that programming in the display instead of dumping each and every one into the main board. And the reason for that is in our original control, every time you made an adjustment, the boiler would start and stop, because we were programming to the board. It stopped, we uploaded. So now it holds everything in the display. When we're all done, it's going to dump it to the main control board. It will turn off and back on as far as the firing of the boiler. So that's why we do it that way now. If you forget to upload your parameters, though, at the end of the day, it doesn't hold it for you. When you come back next day, you're going to have to add them all again. Password. Password is 5309. That is every Lochinvar boiler out there uses 5309. And yes, that is from the Tommy Two-Tone song, and that is Jenny's phone number. To get to where we enter the password, the menu button, push and hold that. Now again, push and hold it for 5 seconds. We take a few calls every year, somebody saying, hey, it's not working, I'm holding this for 5 seconds. So if you then say to them, hey, hold it until it says enter password, they're much more successful. So hold it until it says enter password. Like I said, it's a southern boiler, and things move a lot different in the south than they do up here right now. All right, so once we get that done, use our scroll knob to set it, save it, and now we'll take us into the programming. All right, so now let's talk about menus. Now, talked a little bit about the fact that we have the first generation, second generation, third generation control for our residential products. And then we've actually moved to this whole new, really cool control for our commercial Crest boilers. It's awesome, touchscreen, really cool. But all the menus are the same. So if I go back to 2005, the menus behind the scene are the same as the menus they are today. What's even more important, if I take a boiler from 2005 and a boiler from 2020, and I connect them via Cascade to each other, they can actually communicate and work together. So it's a pretty cool feature that we've got there. So use the knob to scroll through there. You see that little tough to see, but there's a little arrow right now that's aimed at general. That's telling you which menu you're going to go into. Okay. When you push it when it's lined up, now you're going to get into the sub menu. Same story. See the little arrow? When you get to that one, push it, and now you can make a programming change. And this is faded out because this will actually flash to let you know you're programming this parameter right here. When you're done programming it, hit that save button, and then you're going to hit the exit and go back. When you're all done, you hit that home key. All right. So what are the parameters and what's in there? Kind of walk through that a little bit here. So general menu, not a lot of exciting stuff inside the general menu. What I have is really I can set time and date. I can set my my software versions in there. I can look at it. I can't really set it. I can change my temperature units, Fahrenheit to Celsius, and I can get in some night setback adjustments there. Now, your time and date is important if you're going to set the service maintenance reminder, okay? Software version, that's more of something that if you were talking to us or somebody down in Tennessee, we want to know which version of software was on that particular board. This is where we're going to find it there. Temperature units, Celsius and Fahrenheit. I think that's pretty self-explanatory there. But let's talk about night setback. So night setback is kind of a unique feature in the fact of we put that into the boilers very early on. I mean, I think it was in the first generation. And so when the boilers were coming out, the building management systems like you see today were not nearly as robust as they are today. And this was a great way to give you a little bit of energy savings. So you could program the boiler and say, hey, 9 o'clock at night, I want you to lower your temperature. And maybe 5 o'clock, I want you to go back to whatever your regular temperature is. And that's this night setback. So whatever you set in there for a temperature, a number of degrees right here. So if I set that to 30 degrees, when I go into night setback, I'm going to deduct 30 degrees from my targeted water temperature, including wherever I am for outdoor reset. Residentially, probably not a solid idea to use that one. This is more for a light commercial type of scenario. I might want to use that there. Maybe I've got a warehouse. Maybe I got a building like ours down at FIA. Maybe I'm a supply house somewhere along there, and I just want to. I don't want to run the boiler at 180 or 140, whatever it is. I want to save something at night. So it's a way to set that in there, drop your temperatures down. But again, residentially, could bite you in the rear end. And you'll set your trigger times. So you could say, hey, Friday night, I want you to come on. And then Sunday night, I want you to go back to your regular scheduled programming. Okay. So it gives you start and stop times. Now this one here, this is a more common feature that you're going to use. This is your night setback temperature. So this one here, I can tell my boiler not to make domestic hot water at night. I tell my boiler not to make domestic hot water at night. So I do is about 9:30 at night. My boiler will lower the targeted temperature in my tank. So it drops it down from 124 down to 94 degrees. What that does, it just prevents the boiler for that little short cycling of turning on. Comes back on in the morning, runs the tank up to temperature. But what I've done is I've held it back enough that I put a bigger load on in the morning, as opposed to maybe firing once or twice in the night. Just going to fire once in the morning, and it's going to take care of that. Think of doing this at a business that's closed for the weekend, and you can actually shut that down for Friday at 5 till Monday morning at 6 in the morning. You take a lot of cycles out of the boiler, and the cycling is important. It's big for efficiency as well. And it's the same story. Set your start times and your stop times. You can set up to 6 of these different triggers. So I talked about, we come on for the display lights up. In this case, it's 3 minutes. If you need it longer, you can adjust it there. And when you walk away, it's gonna go off. All right, just talk a little bit about temperature settings here. All right, so just some terminology we'll go through, and notice the one, SH1. So there's 3 set points. I can set all 3 set points different, okay? So space heat 1, I have a minimum and maximum space heat set point. So that minimum maximum, that's my operating window, if you will. I could use that for a couple of different things. One is maybe I'm operating within a heat pump loop, and I want to set a maximum never to exceed type of temperature. I'd go into my max space heating set point and say, hey, I don't ever want to exceed 140 degrees or 130, whatever it is. Minimum at 32. This is, a lot of times I look at this, this is your homeowner protection right here. We all know that you put this in, the homeowner's going to be excited, the facility guy's going to be excited, whatever it is. And they're like, hey, I'm going to go down and touch the control and make an adjustment without knowing it. And all of a sudden they've set their space heat set point to 60 degrees. Then they call up, I got no heat. So you may want to look at, hey, what's the minimum temperature I'm ever going to let this boiler go? There's your minimum set point. Set that. The homeowner or whoever can't go below it, prevents a callback. Now offset, our offset works with our differential. And what it does is it works something like this. If I am targeting 170 degrees, that's based on my outdoor reset calculation, whatever it is, 170 degrees, I set my offset for 10, which is the default setting. Basically, when my boiler gets to 170, I'm going to idle. Now, if I reach that 10-degree offset of 180 degrees, I will shut off. And then my differential comes into play. And I will cool down to that 160. When I get to 160 or 20 degrees below my offset, I'm going to fire back on. So these are adjustable. Now, why would we adjust them for different things? Well, sometimes we look at, maybe I want to be a little more responsive with my boiler. Okay, maybe I've got a smaller boiler and a big massive load, like not by talking about BTUs, but I'm talking water content load. And I might say, hey, I don't want to drop 10 degrees below my set point with so much water, and then it's going to take me a little bit of time to bring it back up. Maybe I shorten that differential up a little bit. Maybe that's a 16-degree differential, so I don't drop down as far. Or maybe I don't want to overshoot as much, or I want to allow my boiler to overshoot more. Want to give it more landing strip and runway. So, for example, I run my boiler here at my house very, very cool. And then I run like a 20-degree offset. What that does is it gives my boiler room to idle. Its goal is once it crosses that set point, I'm going to be at an idle, but sometimes in a very low load condition, even at the minimum firing rate, that boiler's still going to kind of creep up. So if you give it a little more room to run, it'll keep it from shutting off and then coming back on again. So again, you can set them for whatever works for you. If you're operating a heat pump loop, when we are in heat pump loops, a lot of times we have a 3-degree offset and a 6-degree differential. Now we got a really tight window for that boiler to operate in, because those type of systems don't want to see big swings. So they can all be set up differently, and it's always customizable for whatever you got. All right. You said there's 3 of those. So it's 1, 2, and 3 that you'll see within there. All right, let's jump into data logging a little bit. Really, that's just to track and reset your log errors. So my recommendation to you is when you initially start your boiler up, if you're there and you're messing around with it and getting everything done, purging the air, purging the gas, whatever, reset your log errors before you leave. I'm notorious for it. If I come to your job and I'm working with the inspector and we test all the safeties, constantly I'm forgetting to do this before I leave. And then all of a sudden the next guy in goes, man, on one day they had 10 errors. What was it? This is a good way to just clear all that out of the memory so it's not there for the next guy. All right, so I got a little bit about some functions in here. Not a lot in functions, but we really talk about our service mode delay and our freeze protection. So what this is showing us is at 45 degrees out, or 45-degree water temperature in the boiler is going to go into freeze protection and turn its pump on. At 37 degrees, it turns the boiler on, and it's going to operate a 5-degree differential. Okay, so that's where that boiler is going to operate in. Okay, let's talk about some domestic hot water settings. A lot of these only work if you have put the tank sensor in, and that's where the boiler is now reading the temperatures. So boiler set point, and this comes defaulted at 180, and it should almost never be 180. So this is the temperature that your boiler is going to run to, firing to heat up its boiler water, is that 180 degrees. That's where this is going to run to. And I'm talking about it in just a second. And it's got a tank set point of 125 degrees. There's always a lot of debate on what my tank set point is, but your boiler set point should probably be about 20 degrees above your tank set point. Now, it's not a one size fits all. There are going to be those days that, hey, maybe this indirect's a little bit undersized. So I got to run it a little hotter. I've got to run my boiler a little hotter to recover it. But as a general rule of thumb, 20 degrees above your tank set point, and you're going to heat your domestic hot water just fine. Again, I like to use my house as an example. I'm at 124 degrees right now, my tank set point, and I run 146 degrees for my boiler. So if you look at it, if you watch my boiler, it's almost always condensing. Even in a domestic hot water call, the boiler's condensing just because of those low temperatures. Tank set point differential, that is, so 125 degree tank set point, a 6-degree differential. That means is at 119 degrees in the tank, the boiler is going to kick on to put that water out. Where would I, or turn the boiler on? Where would I adjust that differently? Where the question really becomes, where's the set point, or where's the sensor in your tank? If my tank sensor is higher, my differential is probably a little tighter because I want it to come on sooner because I've already burned through the bottom of my tank. For Lochinvar, our tank sensors happen to sit pretty low in there. So we can run a little wider. In fact, you'll find most of the time when our tank sensor sees that colder water, we hit that differential. If you were sensing the top of the tank is still probably above the tank set point temperature because we have such a broad range. So just look at wherever your sensor is within the tank. The boiler offset, DHW boiler offset, that works just like our space heating one did, offset and differential. How far above target do I go and how far below, okay? Domestic hot water switch times. So this is your priority override. If you have piped your indirect directly off the boiler, what you're going to, and you're worried about it staying in domestic hot water production mode and not heating, you can set this up right here. You can say, hey, after 30 minutes of domestic hot water production, no matter what, I want you to come back into space heating. I've only once actually seen it where somebody was using so much hot water that the boiler didn't come back, and they actually had the house start to go cold. More often than not, somebody's had a pump failure. The domestic hot water is not satisfying. It's calling, calling, calling. The boiler doesn't go back into space heating. Well, this is going to come out of the box set to go back into space heating after 30 minutes. Minimum maximum set point. Again, keep your homeowners safe from themselves right here. Usually that max set point should probably be somewhere around 140, 130, depending on whether you have a mixing valve or not. Again, keep them from setting it and scalding themselves. And then your minimum set point there, you know, if you want to keep them away from a no hot water call, you know, where they adjust that and get into it. Let's talk about types of domestic hot water. Boiler will operate what we call normal or zone. Now, normal is I'm piped right off of my boiler. Okay, so in that situation, I am shutting off the boiler pump, which you see right above the domestic hot water takeoff here, and turning on this domestic hot water pump. So I will not pump up onto the loop. Now that's the default setting for the boiler. Your other option is to pipe as a zone. And I apologize, it's a pretty busy drawing here, but in that case, my domestic hot water is piped up here, just like another zone of heat. And what my boiler now knows is, hey, keep that boiler circulator on and put the hot water up on the loop so that the domestic hot water circulator here can pull it down. One of the advantages to domestic as a zone is the fact that you do heating and domestic hot water simultaneously. You're going to put the water up there on the loop. Domestic hot water max fan. Now this is a pretty cool feature. We generally find a lot of times a boiler is oversized. Sometimes for the domestic hot water, we are beginning to see more where the domestic hot water is actually larger than the heating load. But if you have the case, and this might be more of a light commercial type of application, you put a 500,000 BTU boiler in and a 40-gallon indirect, obviously way too much boiler. So we want to slow the boiler down, and we can tell the boiler to slow down. And that's where we get into a little bit of math. I'm going to use a 40-gallon indirect and a 285,000 BTU boiler. And basically take the gross, the input coil capacity of the indirect, the gross output capacity of the boiler. You do a little math. So it's 44%. That's all of the boiler I need to be able to satisfy that tank. Anything other than that, the boiler is overfiring and is going to begin to cycle just because there's nowhere to dump those BTUs. So 5,200 RPMs is the maximum fan speed of that boiler, which you can find by going into the actually domestic hot water settings, and the boiler will tell you what its maximum fan speed is. You do the math, comes out to tell you 2,288 RPMs is what you're looking for, and you would actually go in there and set that maximum fan speed to 2,300 RPMs. And on a call for domestic hot water, that's as much a boiler as you're going to fire, and that's going to keep that boiler from overfiring, being unable to really dump the energy. And if you think about it, I put a 40-gallon indirect on it, and I fire that boiler at full capacity, I'm looking for 26 gallons a minute, and you just can't stuff 26 gallons a minute through that coil. That means is you're sitting there cycling your heat exchanger on and off, up and down, up and down. That's what we want to get away from. So I'm sure you won't have a 26 gallon a minute pump. There's a pretty good chance you got a 12 gallon a minute pump, and that's going to allow the boiler to operate with that 12 gallon a minute pump. All right, that's where it'll show up our fan speed. All right, let's talk about outdoor reset. I'm a little disappointed that Bill Brose isn't here because he's been on my case to fix my slides that we'll get to in just a minute here. So in outdoor reset, we talk about low, high, and our set points, our outdoor temperatures. So we really have there's 5 points, but there's 4 important points. The outdoor low, that's my temperature outside, to correspond with my set point for low, and that's usually the higher water temperature. So the higher water temperature at the lower outdoor temperature, the higher outdoor temperature with the lower indoor water temperature. Okay, so that's how those go together. And when you program them, what they're going to do is they are going to create something that looks like this. They're literally going to create this outdoor reset curve, if you will. Now, one of the things that in my original slide and why I had to change it, we always talk about, 10 to 70. And we were setting the end of our curve at something like 70 or 68. But usually we have the heat off. So I recommend you kind of bring that back, setting it basically at 60 degrees. So now I'm going to drop my water temperature down to the lower spot at 60 degrees out, and I'll be able to get those savings from 60 to 70 degrees or 68 degrees, wherever it is. We just pick up a few extra therms of savings every year, and that's the important point of these, is getting those extra therm savings. So in this case, my outdoor low is set for 10 degrees. So at 10 degrees out, I'm going to go to 170 degree water. Why 170? Because we have a 10-degree offset. So 170 will get you to 180. Okay. Our outdoor high at 60, I'm going to set that for 110. And this is just some numbers that, that I picked, random numbers. So at 60 degrees out, 110. What this does is basically at 50 degrees out, I'm running 130 degree water. And at 30 degrees out, I'm running 150 degree water. And that's kind of how that slope works. And we debate outdoor reset all the time. How much should it be? Where should it go to? What's the settings? Everybody's got their choice. And I think it's next week, George Carey's going to do a class on outdoor reset, and really some eye-opening numbers at how often we're not at design temperatures and wherever we are, and really where we can get the savings. And it's crazy numbers. It's like 80% of the time you need less than 50% of the BTUs. If you have baseboard, the way to get down to 50% of the BTUs on baseboard is 135 degree water. So you can kind of take a look at that curve and say, well, I bet you we spend a lot more time below 50 degrees where we could probably be closer to that 130. So definitely some things to look at in adjusting your outdoor reset curve. And this is just, you can set them all up 3 times. Now, where would I use those multiple curves? In settings. This is kind of an example of that. One is overcoming setback thermostats. So people still like to set their temperatures back at night. In the morning it comes on, the boiler's 10 degrees away from set point. We've gotten aggressive with our outdoor reset curve, and they can't bring it up to temperature. And the phone call is, man, my boiler ran for 4 hours and my house still only came up 5 degrees. So the answer sometimes becomes, well, I'm just going to take the outdoor sensor off. So now our night setback thermostats just ruined all of our energy savings. So we have the ability there to take a 2-stage thermostat. Basically, the first stage call, I don't know why I'm clicking on it with my pointer here. Doesn't do you guys any good. My first stage call comes right over here. It's going to turn my pump on. It's going to turn my boiler on. When I need that second stage call, when I'm coming out of that night setback, here's what I'm going to do. It's going to go over here and tell my boiler, hey, raise the water temperature. Whatever you set it for. Maybe this is a fixed 160 or 170 degree number, whatever it is. And it doesn't always have to be higher. So if I set this for, I'm going to say 160, okay? And my first call here was looking for 130. I'm going to get that 30 degree bump in temperature until I get close enough that my second stage drops out. If I'm cold enough that this is looking for 170 or 180, a temperature above it, it'll default to that temperature, the higher temperature. So it doesn't always have to be the higher temperature, but just be the one that you want to use to boost it up. So it's a feature that's there. Most often I've used that in cases where it is in churches. It's the most common spot that I've used that. And we'll use it in this might be the sanctuary here on room thermostat 1. and we're running hydrowares, and all we want to do is we want to keep the frost off. Um, you don't want to make all the critters happy by making it so warm in the sanctuary they're coming in, but maybe they keep it at 50 degrees. And then come Sunday, they want to bump up the temperature. Well, that's this call here. That's maybe always 170 no matter what. So when that 2-stage thermostat says it's Sunday morning, crank it up, the boiler automatically raises its temperature. So it's kind of a cool feature. It's there. All right, and again, you set them up multiple times. 1, 2, and 3. This thing down here at the bottom, boost temp, boost time. This is your other backup. You don't want to put a 2-stage thermostat in. Customer still wants to use night setback, and you want to use outdoor reset because you went out there and said, you put this boiler in, you're going to save gas. And if they rip that outdoor reset off, they're not going to save any gas. Well, boost temp, boost time allows you to say, all right, if my boiler has a sustained call, and let's just say we program in here in this boost time 20 minutes, it will automatically boost the temperature by whatever you tell it right here. So maybe say, hey, you got a sustained call for 20 minutes, bring it up 15 degrees. If it goes another 20 minutes, bring it up 15 degrees. And it'll automatically boost that temperature up for you. So you can be a little more aggressive in your outdoor reset. And then your boiler's going to say, all right, so whatever happened, I'm going to boost the temperatures. Whether it's a power outage, whether they shut the thermostat off, forgot to turn it back on, any of those sort of things. It happens in my house all the time. The weather gets quasi-nice, and by quasi-nice, it's 48 degrees out. My wife decides she's got to have a window and a door open, cranks them open, shuts the thermostat off, and then all of a sudden it's 50 degrees in the house and cranks it on. And because my water temperatures run real cool, my boiler might go a couple of weeks before it would ever get back up to temperature because it's not designed to make that big jump. But that's what that's going to do for you right there. It's kind of solve that scenario. All right, a couple of mountains, right? A little earlier, I'd mentioned about ramp delay and how we could cap the size of the boiler on the top end. The other thing we use ramp delay for is to stop this. So I really think inside the smart control, there's like a 17-year-old boy with a set of keys to a Corvette. And that's how the boiler operates. Call for heat, pedal all the way down. I'm going to go as fast as I can. I see the stop sign. Stop sign's getting close. I'm at the stop sign, slam on the brakes. And then I'm going to do it again. And that's some of that internal logic because it wants to go. Well, ramp delay, and we've put some mild ramp delay in there to kind of slow everything down, but you can really get aggressive in that ramp delay. Where would you do that? Well, let's go to the scenario where now when we're sizing up boilers and we're looking at things, you know, people have a jacuzzi tub. I need an 80-gallon indirect. I need 200,000 BTUs for my 80-gallon indirect, but my house is like 50,000 BTUs. Or I had 4 zones, but geez, 8 zones will be better. You got to slow the boiler down. This is what ramp delay gives us that ability to do. So we jump into our anti-cycling menu. We go down here to ramp delay and we're going to enable it. And then just like we had in those night setbacks, we set stages. We have 6 stages for a delay and a limit. It ends up looking something like this. So now my boiler fires, my first stage there is 20%. Set it for a couple of minutes. Be as aggressive as you feel necessary. Look at your house design, your system. If I have hydroware, I might be a little less aggressive on the front end just because I want to get a little heat out there. I don't want to blow some cold air and that sort of stuff. They'll get frustrated. If I have baseboard, if I have radiant, if I have snow melt, any of that sort of stuff, be aggressive in slowing that boiler down. So go back, we talked about cycling. We want to see no more than 6 cycles an hour in a fire tube design and no more than 10 cycles an hour in a water tube design. And that really gets into the water content of the 2 heat exchangers, why there's really that difference in there. But if I want 6 cycles an hour, I want a 10-minute cycle. If everybody, whenever they put one of these boilers in, set those first 2 stages at 5 minutes apiece. Maybe you got a 10-minute or a 5-minute with a 10% or a 15% firing rate. And then you go to your next one, another 5 minutes, bump it up another 5%, whether that becomes now 15 or 20%. You hold the boiler back, you allow it to take some time, you build in that automatic run, which is what the boiler wants. It wants to run. We're going to get some time where we're condensing. We're going to be able to run clean. That's the big part, is your boiler burns clean. It doesn't cycles on and off. Side benefit of that is things like if you slug, so back when we all had cast iron boilers sitting down in our basement, they were hot, and you turned a zone on that might have been off for a while, and you slugged 180-degree water into it, you got that tick, 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 tick of the baseboard, and you got all the noise and everything else. Well, because I don't have a big reservoir of water down there, and now I slowly heat my water, I really take a whole lot of that expansion and contraction noise out of my baseboard. But the other side of this is we talked early on about offset and differential and how we're really designing to get the boiler to stay running and to coast in there and to do that. And if you tune in and see George later on about outdoor reset, it's an eye opener when he gets into there next week. But everybody overdoes their outdoor reset curves, because when we put into it some of the Techmar controls that do our indoor feedback, we're shocked when we see what the true numbers are. I think I do pretty good. The other day I was targeting like 108 degrees. We had somebody on the seminar, he was at like 72 degrees. It's just amazing the difference that we'll see. So we're always looking to get the boiler to modulate. It's what we want to do. Boiler's logic though, you gave me a water temperature, I go to it, now I'm going to modulate. If your water temperature was too high, you never modulate. Here, you create the modulation on the front end. So if you say, hey, I want you to go to 140 today, maybe you only need 110, but you've set up your ramp delay, you've done that, your boiler does not come on and go to 100%. Your boiler comes on and goes to 10%, and it idles along, and it satisfies, maybe it's at 10 or it's at 15% and satisfies. We modulated our boiler. We didn't fire it up like crazy. We didn't create all this excess wasted energy. We extended out our cycles. And what we're doing is we're targeting much better to get to our water temperatures. This is what we're doing. I bet if you go down and watch a lot of boilers that are set up with that 140, 180 outdoor reset curve, you're seeing that things are satisfying long before they get to their targeted water temperatures. So it's just one more piece of the puzzle that you can put together to kind of tie in this, hey, how am I going to do a good job making my boiler as efficient as possible? All right. Control modes, not going to spend a bunch of time here, just really let you know that they're there. But this is really where we're going to get into talking about in the control BMS. Residentially, one of the times we'll use this is if you're using some sort of external indoor feedback control, Techmar indoor feedback or Techmar's room response control, where it's feeding back to the boiler, giving it a design water temperature. You can also connect it to a building management system. So our 50,000 BTU boiler has all the same abilities as our 6 million BTU boiler when it comes to this BMS communication and stuff like that. So if you want to put a full BMS system inside your house and connect to your boiler, it'll do it. It'll communicate to it. All of that's going to be in there. Do you want to talk about Cascade? So Cascade is the ability to put multiple boilers together and let them work. So in my house, I actually cascade 2 small boilers. I have a 100,000 BTU load for my domestic hot water. I got a 35,000 BTU load for my space heating. In Massachusetts, where I am, you can collect 2 rebates. So you put 2 boilers in, they pay the rebate twice. So I put 2 50,000 BTU boilers, and I almost think I might take them out and put 2 new ones because they're like 7 years old, but the rebate's like $2,700 now. So definitely pay for the boilers. But so you do something like that, it becomes pretty lucrative for the homeowner in the day. But this is where you set it up. So Cascade address 1 is actually the first member boiler. 0 becomes the leader. Select your Cascade type, lead lag or efficiency optimized. Most often in a residential application, we use that lead lag where we're going to run 1 boiler as hard as we can until we can't keep up. Then we kind of bring that next boiler on. But we'll generally run 1 boiler to like 90% before we're going to fire off a second boiler. In efficiency optimized, we have them run together. So there's your modified lead lag. This would be your efficiency optimized. We'll see this commercially. We see it in full flow applications, just keeping multiple boilers running instead of having flow through an off boiler and those type of setups. But that's more of a commercial application. Cascade offset and differential works just like our regular space heating offset and differential. Where do I go above? Where do I go below? Circulation pumps, kind of a new feature. Well, I take that back. It's not a new feature. We put it in the boiler in 2010. And when we got it in 2010, those of us who looked at it said to Lochinvar, have you lost your minds? Nobody has a pump that does what your boiler will do. Well, guess what? Now we actually ship the pump with the residential boiler. The boiler will send a 0 to 10 volt signal to the boiler pump to change its speed based on the delta T through the boiler. So as my boiler downfires, so does my pump. So if I'm only running, go back to that 285,000 BTU boiler, 26 gallons a minute, and I'm running 100,000 BTUs, when I'm doing that, 16 gallons of that 26 gallons of water that I heated up turns around, comes back to my boiler. Not anymore, because now it's going to ramp it down. It's going to slow the pump down. Now, if you write anything down from today, if you remember anything, all you need to remember is blue 42. Most common question we get is, where do I connect these wires? Well, the blue wire goes on terminal 42, and the other wire goes on the other terminal, which is actually, I believe, 41. So brown 41, but blue 42 is the answer to that. Now, if there's any electricians here today, the wires that we send with it are the low voltage wires. It does need the 120 volt wires run to it. The reason we do that, and you're going to tell the boiler it's a variable speed pump, because there's, in a sense, there's a drive in there. There's a little VFD drive, if you will. We keep that pump powered all the time. The boiler turns it off using the voltage, the 0 to 10 volt signal, turns it back on doing that. So it's kind of a neat little feature that's right there in the boiler now. Pump delay. How long does my pump run after its call to run is over? Whether it's a system pump delay, boiler pump delay, domestic hot water pump delays. I would recommend your boiler pump delay and your domestic hot water pump delay. The higher your boiler temperature setting is for your domestic hot water delay, maybe the longer you set that to run. Okay, so if you're running to 170 for domestic hot water and you're storing a tank at 130, you might give that a 2-minute delay. And all it's going to do is continue to run and dump the rest of that energy out of the boiler, put it in your indirect tank where it belongs. Okay? Anti-seize, so if the pump goes 24 hours without a call, it's going to turn on and run automatically. Way back in the original, this was back in 2005, they put those in there, and you couldn't adjust it, so they didn't tell anybody. You know, they didn't market it. And then you get a customer every once in a while to call it and be like, my pumps are running. You're like, no, you must be crazy because your pumps aren't running. And you can never catch it. And then finally it was like, oh yeah, it is, because every day it cycles those pumps through. So it's kind of cool. Boiler pump minimum voltage, that's going to be set for 3.5 volts, and that's the minimum rate that it's going to run that pump. Now on the display screen, it shows you your boiler pump rate output, doesn't show you the voltage, and that on the screen would show up as 35%. That's where it's dropped that pump down to. BMS, I said, with all kinds of settings in here, so this is where we get into setting up what we're doing. If I'm using like a Tecmar room response, I set that up for set point control, and I interpret the voltage coming from that Tecmar as a set point. That tells my boiler where to go. Now we step back a few years when we were using the classic type Tecmar controls, and they were giving it a firing rate. We would set that up as a power signal, and the external control would tell the boiler where to go as far as a firing rate. Generally, you want to stay away from telling the boilers a firing rate, because that's what they do, and it overrides a lot of their internal logic sometimes. But set point is always the way to go. Just give it a set point demand. Okay. And we got service notification. So service notification out of the box now, I think it's still coming at 0 months. And the reason is it used to come with a 12-month setting, and you got the boiler, and whatever the date those boards have been programmed was the date it had, and you set the date out of the box. And then I think there was a vicious streak in all the boilers. And what it did is it now said, hey, the date my board was programmed was 2014. You just told me it's 2020. And you said that I should tell you every 12 months that I need service. So then it used its proximity detector of where's your van. And as soon as your van backed out of the driveway, it would trigger service notification, which was outstanding because homeowner came home. They're all excited. They go down and say, why does my boiler need to be serviced? So we now have you set that runtime in there when you set the date, just so it wasn't giving you that little premature thing. Because everybody really liked that service call. Hey, I just got home and my boiler says service due. Another thing to think about is if you do go out to a boiler, so like right now we're seeing not so much residentially because nobody wants us in their houses, but we're seeing commercially buildings that are shut down pulling forward their PMs. Okay, my son's school just did that. They the company that services them just went in and serviced all the boilers. They did it like 2 months early because they were shutting everything down. Didn't matter. But you need to reset that maintenance reminder because otherwise at the normal maintenance time, it will trigger. So when you do that, make sure that you kind of clear that maintenance reminder. And this is where you reset it. We're in the programming. We've done it. We've gotten into the service notification. We go to reset maintenance reminder, and we're going to hit yes. From there, here's where you program your phone number and name. A couple of important things. If you like the customer, put your name and phone number in there. If you don't like the customer, put your competition's name and phone number in there. If you really don't like your salesman that you purchase your stuff from, put his name and phone number in there. It doesn't matter, but that will come up. In fact, one of our sales guys, his brother, put a very nice message in their own boiler. So they got a nice message when that thing triggered. But definitely, put in there whatever you want, but I'd recommend it. If you take over a new customer and they've got a Lochinvar boiler in there, it's been in a year, 2, 3, 4 years, whatever, make sure that not only do you put your sticker on the side of the boiler, but go program your name and phone number inside of there. Otherwise, when that triggers, they'll get the old company's information. All right, so any questions? Anybody, if you want, you can unmute yourself and go ahead and ask away. All right, I like it. No questions. All right. Well, nobody's got any questions. I think I've got it so you can unmute yourself. I didn't see any pop up. I'll shoot you guys out an email with just a link to some stuff. If you got any questions, go ahead and email back. If you are interested, at the end of this week, we're actually going to do a tear down on a boiler, take it apart, clean it, hopefully not break it in the process, and then fire it back up. So that's going to be Friday this week. And just so it's not boring, we'll actually pre-check everything and make sure all the bolts will come out as opposed to having anything like that happen in the middle of it. And that way we can kind of keep it under an hour on Friday. But we'll be doing that and a combustion analysis there at the end. All right.
Awesome job.